Today, I wanted to go over an FRQ from the AP Physics 1 2015 exam. So in two previous videos, we've already gone over number 1 and 3 of the FRQ. So today we're going to move to number 4. And number 4 is about free-falling objects. So we have two identical spheres that are released from a device at time t0 from the same height h. Sphere A has no initial velocity and falls straight down, and sphere B is given an initial horizontal velocity of magnitude v0 and travels a horizontal distance d before it reaches the ground. The spheres reach the ground at the same time, even though sphere B has more distance to cover before landing. Air resistance is negligible. Okay, so let's look at question part A. So question part A tells us that the dot below represents spheres A and B. So it asks us to draw a free body diagram showing and labeling the forces, not components, exerted on each sphere at time tf/2, which is basically the total time of flight divided by 2. Now, what do we know about this problem? We know that these objects are free falling, which means that the only forces that should be acting on them is the force of gravity. And the force of gravity, let us go back to the problem. The spheres are identical, meaning their mass is the same. So that means the force of gravity on them should be identical. So using the lines that they have provided for us, we're going to draw the force downwards as the force of gravity. And then this is MAG, and this is MBG, where MA equals MB. Okay, so that was a pretty easy first question. Now, moving on to the second question. So the second question asks us to sketch and label a graph of the horizontal component of the velocity of both A and B as a function of time. So let's start off with A, since that seems a little bit easier. So A, as we can see if we go back to the problem, A had no initial horizontal velocity given to it. So A, no initial horizontal velocity. So that means that throughout the entire time of flight, the velocity of A in the horizontal direction should be 0 because there was no initial velocity given in the first place, so there shouldn't be any throughout its entire flight because there's no horizontal forces acting on it to accelerate it or give it a horizontal component of velocity. So that means I'm going to use red for A. So A is going to have a velocity of 0 throughout the entire time, and we're going to label it because that's always good practice on your FRQs. Now for B, we're given that it's given a horizontal component of velocity at time t0 with magnitude v0. And if we think about it, the horizontal component always remains the same throughout the entire time of flight because there is no horizontal force acting on it, as we mentioned in part A, because the only force acting is the force of gravity. So if we arbitrarily choose any point on the graph as v0, we can choose, let's say, this point as v0. We can draw a line here, and that will be the entire horizontal component of velocity for B throughout the entire time of flight. Okay, so this last problem here asks us to write a paragraph. I won't be writing a paragraph, but let's just go over some of the components you would need to make sure you answer this completely. So it says that the spheres reach the ground at the same time, even though they travel different distances. So A travels a distance of 0 and B travels a distance of d as given in the question. However, they both take the same amount of time, and that's because it relies on the height h that they have fallen. And height h of A equals height h of B because they're falling from the same point on the same device. And also, they start with the same vertical velocity, okay? Now, A is dropped, which means Vy initially equals 0. B is given a horizontal velocity initially, which means that Vx equals V0, but Vy also equals 0 initially. So that means they have the same vertical velocity initially. And this means they will fall the same height with the same time. Both of them have the same acceleration, which is d. They have the same height to travel, which is h. And they have the same initial y velocity, which is 0. And if we think about it, if we look at this equation, we know that delta y equals v naught times t minus 1/2 g times t squared. And because v naught in the y direction is 0, that simply becomes h equals negative 1/2 gt squared. Sorry, negative h, because they're falling a distance h. So if we look at that, since h and g are the same values for both, then that means t must also be the same value for both. Now, that would be a way to get all points on the last part of the FRQ, but of course you would need to write it in a paragraph form. But on the real exam, just include all of these points in your paragraph and you would be getting the full points on this FRQ. So this was a pretty short FRQ and it was pretty nice and sweet, easy. So I hope this helped you. If you have any questions, leave it in the comments down below and I will try my best to answer them.